There's something even more interesting we can do with lists. And instead of processing one value at a time, we can start understanding the collections as a whole. We don't just ask, what is this one value? A lot of times we ask, what's the average? What's the highest reading or the lowest reading? Is the overall system stable or not? So lists allow us to analyze collections of data together. It can answer those questions for us. Python already includes powerful tools for working with lists. Let's start with the average. How do you find the average of a collection of data? Let's keep the temperatures list, and then let's call the average temperature, which is going to be equal this. The sum, as you can see, the sum of the temperatures list, close the bracket, divided by the length of temperatures. Let's unpack this. Sum of the temperatures means this: add all the values inside the list together. And LEN, which stands for length, means count how many items exist inside the list temperature, which is how many we have. 1, 2, 3, 4, 5. Okay? So if I just remove this right now, okay? And then just say print LEN of temperature. What do we get? We get 5. 1, 2, 3, 4, 5. So length, count how many items exist inside the list. So this line here, average, is doing basic average calculation, total sum, divided by number of values. Let's just say print average temperature, and then give me the average temperature value. Here we go, 27.6. Now we are no longer looking at individual values. We're understanding the behavior of the entire collection inside that list. Another thing is Python can do with lists, we can also quickly find the highest and the lowest values. Let's do that. Let's just keep this one, and let's just say print highest, like this, temperature. And then here I'm going to say max of the temperature list. And then also I'm going to print the lowest value, the lowest temperature value inside the, here I'm just going to say min temperature, the minimum value inside the temperature list. Let's run it and let's see what that means. Here you go. The average, as we know, 27.6. The highest temperature value is 33, and the lowest temperature value is 22. So now our system can store data, process it, and analyze it. And this is exactly what happens in real engineering systems. If you have a drone might analyze average altitude, peak vibration, lowest battery voltage. And if you have an AI system might analyze thousands of training values, probabilities, confidence score. All these things, you can find it through lists. And notice something important. We are still using the same foundation. Variables, loops, conditions, lists. Complex systems are usually built from very simple building blocks, and they are combined together carefully. So far, our lists have only contained numbers, right? Temperature readings, sensor values, measurements, but lists are much more flexible than that. Imagine we want to store system names. Okay, let's do that. Let's say system is equal to cooling, for example. Another one would be navigation, battery, and then lastly, let's just say what we deal with, which is sensors. Instead of numbers, our list contains strings, which are text values. Let's print it out. let's print system. Here you go. So lists don't care if the values are numbers, text, or other kinds of data. And just like before, we can still access individual items. Let's say, for example, I'll just say print system, okay, 1. It's supposed to print navigation. So index 1 gives us the second system name. If I do 0 and then I print it out, is going to print cooling. So index 0 gives us the first system name. Also, we can create a loop that can go through each single one of these texts. And the way to do that, we're just going to say for system, and then I'll just call these systems. For system in systems, print system like this, and then I will call the system that we are printing at that particular cycle. And then let me just clear this out. Let's run it. There we go. System cooling, system navigation, system battery, and then system sensors. So the loop doesn't care whether the list contains numbers or text. The pattern is exactly the same. This is very important programming idea. We just literally created the structure, and now we're using that with text. So once you understand the pattern, you can apply it to many kinds of data, whether it's text, strings, or number, integers, even decimals. If the values here are like 22.3 and 26.1, if I just say print, let's just remove this. If I just say print temperatures, okay, we're still going to get the same thing. We're going to get the list with the decimals, integers, and I can even put here, let's say, cooling. You can guess what's the outcome would be. I still gonna get the same thing. It contains number, string, boolean. I can do here like true, for example. Still, I'm gonna get the list. Python allows this, but in real engineering systems, we usually try to organize data more carefully because clean structure becomes extremely important as systems grow larger. A lot of times if you have a temperature sensor, you're most likely going to deal with values, and most likely is going to be decimal values and integer values. So you're going to get like a temperature that is like 35 point something or straight 35. So now we can store collections of information, process them with loops, analyze them, and organize different types of data. But there's one more powerful thing lists allow us to do. They let systems grow dynamically over time. So let's see what is that dynamic growth is. One of the most powerful things about lists is that they can grow while the program is running. This is extremely important in real systems because real systems continuously receive new information. If you have a temperature sensor or like a humidity sensor, every certain period of time, you get a new information, you get a new value. If you have a sensor keeps generating readings. If you have, let's say, a server, the server keeps receiving requests. Or if you have an AI system, it keeps collecting data. And lists gives us a place to store all of that incoming information. Let me show you that. If I say sensor reading, okay, equal to, open a bracket, close the bracket. I just created an empty list. Notice the square brackets here with nothing inside them. That means the list exists, but it currently contains no data. Now let's imagine new sensor readings arrive one at a time. How do we do that? Okay, well, we're going to say sensor reading. Okay, as we learned, append is when you try to add a new data to the list. And let's put 22 and then another sensor reading dot append and then I'll just add 24. This is like basically, for example, a temperature sensor is reading one data at a time, and then another sensor reading, append, add, let's say 27. Each time we call append, we add a new value to the end of the list. So here, what I'm doing is that I'm calling the sensor reading, which is the one that include empty values, and I'm appending, which is I'm adding the value 22, which is the temperature value. And then I go down here and then I say, okay, add 24 and then add 27. So you can kind of guess, if I print sensor reading here, you can probably guess what would be the outcome. Here you go, 22, 24, 27. So it's no longer an empty list. So the list here is growing over time. But in real systems, we usually don't type values like this manually. Okay, if you have a temperature sensor, it's not going to be like manually I have to append and add each single value's reading, especially if you're reading thousands of data per second or per minute. Values are often generated automatically. So let's simulate that using the loop. And I'm going to use here a package called random. So first, I'm going to just say import random. And this module let us generate random values. And then also I'll just say here sensor readings as I did before, an empty list. And then I'll create a for loop for I in range of five readings, for example. This loop will run 5 times. Inside, I'm going to say reading equal to random. I'm going to call the package, give me the random integer between 20 and 35. This line generates a random integer between 20 and 35. And then after that, I'm going to say sensor readings, append what? Append the reading that I'm going to get from this one. Okay, so basically once you run the for loop, you run the first time, you create a random integer between 20 and 30, and then you store it inside the sensor reading. And then after that, I want to see what's happening. So print the sensor readings for me, or the value that you get created every single time. Let's run it and let's see the outcome. Here you go, 33. So as you can see here, our list is being built dynamically while the program runs. By the way, I put the print here to show you on each cycle. The first cycle, the sensor readings list, include one value, which is 33. So then it goes again and it creates another reading between 20 and 30 and then store it inside sensor readings. So now how many we have? We have 33 and 25, and then do it again and then creates another random, which turns out to be like another 25. It's just a coincidence. And then it creates the list. Now the list includes 3 values, and then 1, 2, 3, 4 values, and then all the way to 5 different values. By the way, if I just move the print here, which if you want to see only the final list, you can just run it and you'll see it'll show you only the final list. The reason I put it inside the loop, because I wanted to show you the loop on every single cycle, how the loop is changing the sensor reading list or its sensor readings list. This pattern, remember, exists everywhere. Sensor pipelines, AI data collection, even network traffic monitoring, runtime logging systems, which we will see a lot of examples in the next videos. This list becomes a living memory structure. You have new information arrives and the system keeps expanding its internal knowledge. But eventually, large collection of data create another challenge. How do we search through all that information efficiently? And that's where we go on the searching part. How do we search within the list? If the system stores hundreds or thousands of readings or usernames or millions of events, the ability to search becomes very important here. So how do we master that? Let's start simple. So we have the sensor readings, and then inside we'll just keep the same values, 24, 31, I remember it was 28, let's just put also 28 and then 35. Okay, imagine I want to check whether the value 31 exists inside this list. Let's say I don't see that list. I want to make sure that 31 exists. How do I do that? In Python, we can do that using the word in. So for example, print, okay, 31 in sensor readings. So if the values exist, is going to give me true. If the values not exist, is going to give me false. All right, true. So if I say here, let's say 55, okay? False, right? So this returns true if the values exist. If it's not exist, it's going to return false. So that's a good way to search for a specific value inside that list. The word in is basically asking, does this item exist inside this collection? If yes, send me a true. If no, then return false to me. And because this returns true or false, we can combine it with conditions. So one thing I can say is this. I say, if 35 in sensor readings, then, for example, print, I don't know, like critical reading detected, something like that. And if I run it, let's see what we get. Critical reading detected. Why? Because 35 exists in the list sensor reading. So now the system can search data, evaluate conditions, and react automatically. This patterns appears almost everywhere. If you have the security systems that are checking for threats or AI systems that are checking for labels, but what if we don't know exactly what value we are looking for? What if we want to scan the entire list for, let's say, dangerous readings? Okay, let's do that. So here I'm going to say for reading in sensor readings, if reading is greater than 30, which is here we have 31 and we have 35. If it's greater than 30, then I want you to print high reading, and then I'll just call that reading. Let's run it. All right, so now I don't know the number, but I set an if condition, or I set a condition that can find if there is a reading that is above 30. And if there is a reading above 30, I want you to print it out. Now you can see what the loop is doing. It's searching through every value automatically, and once it finds a reading that is above 30, it reacts, and it basically gives me the print that we have, whether it's a high reading, critical, something dangerous is happening, whatever it is. This is where lists and loop become incredibly powerful together. Lists organize memory, and you have loop explore memory. As you can see now, we can store data, grow collections, process information, and search through memory, but there's still one more thing, or one more important idea left. How do we remove information we no longer need? Sometimes you have all data expires, or invalid reading must be removed, or completed tasks get cleared, or even temporary information is deleted. Lists allow us to remove values when we no longer need them. How do we do that? So you have the sensor reading here. Let's say that this reading here, 22, is invalid. Maybe the sensor glitched, okay? So we want to remove it from the list. What we're going to do is we're going to call the sensor reading, and then dot, and then we're going to say, as you can see, I mean, you can see it here. There's insert, index, extend, but this is the one that I'm talking about, remove. So remove searches the list for the value we provide and deletes it. What value that we want to delete? 22. Okay, let's print sensor readings, and let's see if let's see if 22 has been deleted. 24, 31, 28. So 24, 31, and then jumps to 28 and 35. That proves that the remove worked and removed that reading. Now the value 22 is gone. But sometimes we don't want to remove by value. We want to remove by repetition. Again, maybe you want to remove the last reading that arrived. Okay, so for example, you have a sensor that is reading 24, 31, 28. That is reading 24, 31, 22, 28, and then 35. But then I don't want that the last reading. So what can I do to actually remove the last item from the list? We can use what is called pop. Pop removes the last item from the list. Okay, so let's do it. We can just basically call the sensor reading, and then it's right here. And then all you have to do is, you don't have to add the value that you want to remove. Because usually pop is used if you want to remove the last item from the list. So if I run it right now, you can see, because I have to print sensor reading. Let's see. Here you go. 24, 31, 22, 28, and then 35 has been removed. So now the last value was removed automatically. And we can remove a specific position. If I want to use pop, for example, and I want to focus on one specific position, I can do that. I can just say 1, okay? And let's see. 24, 31 has been removed, and then 22, and then 28, and then 35. So what I did is pop, which means remove the position 1. So now the value at position 1 disappeared, right? So this matters because real systems constantly manage memory. They add information, update information, remove outdated information. If you have, let's say, a logging system may want to remove old logs. Or if you have an AI pipeline, it may want to clean corrupted data. So lists are not static storage. They are active memory structures that evolve continuously. At the beginning of this roadmap, our programs could only handle one value at a time. We did one variable, one condition, one loop, but now our programs are starting to manage collections of information. Not just one value, but multiple values connected together. And this is really important shift because real systems are constantly dealing with streams of information. You have sensors that are reading data, logs, which we will see in the future examples, messages, temperature readings, let's say, predictions. All these are data that are streaming. And today, we learned how to organize that information using lists. We learned how to store data, access it, update it, grow it, search through it, and process it automatically. But underneath all this Python syntax, we are actually learning something much deeper. We're learning how systems structure memory. A robot navigating a room, or an AI model processing inputs, or a medical monitor tracking signals. All of them rely on organized collections of data. And lists are one of the first real tools that make that possible. But there's something missing here. Right now, our data has one position. We said, okay, at position 1, is 31. At position 0 is 24. But in real systems, we can't really just call just by positions, and we call them by 0 and 1 and 2. We usually think in labels, let's say temperature, battery, status. So instead of remembering where the data is, we want to describe what the data means. And I'll just show you something just for the next video to keep in mind, which we will talk about. Let's say systems, okay, or system, and then I open a bracket, and then I just say temperature, 28, comma, and then I say the battery is, let's say 92, and then I say the status is what is, let's say, active, and then close the bracket, which is already closed. And this is exactly what we're going to do next. We're going to talk about something that is called dictionaries. I'll see you guys in the next video.